Hey everyone, welcome. It's Miss Gubrood. We are on Unit 2. This is lesson number 1. We're going to be learning about area and perimeter of rectangles. So let's get started right away. Take a look at some vocabulary words that we need to know in order to be able to do this. So the first vocabulary word, let's see if I can move myself. Nope, I can't. The first vocabulary word is perimeter. And perimeter is the distance around the outside edge of any polygon. It is calculated and reported in a unit of distance that's measurements such as like feet, inches. So the unit is distance, feet, inches, miles, meters. Now we calculate it by adding up all of the space around the outside edge. We have to just add and add and add and add. Weirdly, perimeter of a circle, though, is not a polygon. Circles aren't polygons. It has a different name. The perimeter of a circle is called the circumference. Now, we have some ideas about how to help you remember perimeter by talking about perimeter person. So let me introduce you to perimeter person. All right, let's talk about perimeter person. So perimeter person was invented in the 6th grade math classroom a couple of years ago when we were trying to remember what the difference between perimeter and area is. So let's make your own perimeter person. This is part of your assignment. You need to do it. It's kind of a fun part. Okay, the very first thing is you need to draw a shape on your paper, or you can do it on the computer too if you'd rather use the CAMI tools and draw it on the computer. But either way, you need to be able to turn this in to show your perimeter person. And then we'll have conversations around this in our small group. So you need to draw some kind of a shape that looks like there's some distances around the outside. Now, it could be, you could just draw a square or a rectangle, or you can make it interesting like I did. So this is the shape that I drew, and then I tried to give them some relative sizes. I said, well, I'm going to say that's 10. So you might say 10 what? Well, we actually need to know the what part in order to be able to give our answer. So we'll say that this is in inches. So 10 inches. Now, if this length is 10 inches, then I said, well, this isn't quite as long. I'll say that's 8 inches, because from here to here, if that's 10, then that's not quite as long. I'll say that's 8. Then I looked at this and said it's almost the same, but maybe not quite. So that must be 9. And then this looks actually is a little bit not quite, doesn't quite so much. Not sure that's exactly 12, but we'll say that's 12. And then if this is 9 and this is 12, then all along here, 9 plus 12 would be 21. So down there is 21. So the only one, I'm missing one, you'll notice, I don't have this length. So that looks like it's not quite half. So I'll call that 4 inches. So you need to make a shape and tell us all of the distances around the outside. So pause the video and do that, and then come back when you're ready. All right, now we're ready to draw our perimeter person. Perimeter is the distance all around the outside of something. So to help us remember, we're going to draw a perimeter person. So it's a person. Yours can be a boy or a girl. I'm going to draw mine a girl because I'm a girl. So there's my person. There they are. There's my person. Now, you can give your person some details. There's my hair. There's my eyes and my nose. There are my arms. Now, your perimeter person can just walk. If they want to walk all around the outside, they can. But walking is a little boring. So you can make your person move in some way that's not walking. Your person could run. So you could give them, like, if I wanted my person to run, I would try to give her like running legs. It looks like she's running. You could skateboard. You could ride a horse. You could ride a bike. So how is your person going to move themselves around the outside? Well, my person, I don't actually know how to skateboard, but I'd like to learn. So my person is going to be skateboarding along. So there it is. There's my person, and she's skateboarding along. So pause and draw your person at the corner of one of the parts of your shape. It doesn't have to be the top left, like mine can be anywhere at all, but put them in the corner. Don't put them in the middle. Put them at one of your corners, and you draw your person. So pause this video, do that, and then come back. All right, you've got your person. I'm excited to see it, who you drew and what details you put on. Now, your perimeter person and mine are going to go around the perimeter. Now, while they go around the perimeter, it's a little like Pac-Man. If you've ever played Pac-Man, it's one of my favorite video games. So if you've ever played Pac-Man, you know that wherever you start, you travel along, and as you travel along, you collect anything that you go. Pac-Man goes along, waka, 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 and eats those little pellets everywhere they go. That's the same way with your perimeter person. So as my perimeter person skateboards along the first part of the shape, they pick up 9 inches. Then they turn the corner and they pick up the next amount of space. So they pick up 4 more. So I'm at 9 plus 4. Then she turns the corner again and she picks up 12 inches. So plus 12. Then she turns the corner and picks up 8 more. Plus 8. She turns the corner. This is a long stretch. She picks up 21 inches. She turns the corner. She picks up the last 10 inches, and she's back to where she started. That's how you find the perimeter. You need to add up all of the distances around the whole shape, and you can't cut any off. You have to go around the whole outside of the whole thing. So the distance that my person skateboarded was 9 plus 4 plus 12 plus 8 plus 21 plus 10. You do that. While I calculate how much that is, I'm going to add that up. You do that for yours. Have your person bicycle or skateboard or rollerblade or walk or run, however they're moving around, literally show, just like I did. I actually used a different color. If you can use a different color, that's even better too. Show how they went all the way around, and as they went, they collected from each side, the distance of each side. So she collected 9, then she collected 4, then she collected 12, then she collected 8, then she collected 21, then she collected 10. Pause the video. You do that on your turn while I add my score up. All right, I added mine up. Hopefully you've drawn yours and added up yours. Mine is 64. What's yours? Now, 64 what? 64 chickens? No, you've got to tell the distance. The distance, each time she skateboarded along, she was picking up 9 something, and it wasn't 9 cupcakes. Had it been Pac-Man, it would have been 9 little power pellets or whatever they call those. She was traveling 9 inches. So if she picked up 9 inches and 4 inches and 12 inches, the answer, when she adds up the whole way she traveled, is 64 inches. And that's a vital part of the answer. So you can't leave the distance out. This case, it's inches. Now, you might have chosen feet or meters or miles for yours. That's fine. But you have to have that label of the distance. So the perimeter, and we'll use P. Remember, anytime in math we use a letter, it just means a number we don't know. So P means the perimeter equals 64 inches. And now we do know it. The perimeter is 64 inches. So perimeter person travels all around the outside edge, kind of like around a fence. And the reason it starts with perimeter and person, because they start the same letter. It's alliteration. Tell Miss Hubacher I taught you that. So alliteration, perimeter person, that can help you remember, and remember skateboarding or bicycling, whatever, around the outside edge. All right, I hope you enjoyed perimeter person. And now I also want to draw your attention to the formula to find perimeter of rectangles. And you can add up all the way around, or you could do 2 2A, here's the formula, 2A, and remember when a number and a letter are squished right next to each other, there's an invisible multiplication sign in there. So it's 2 times A, 2 groups of A, plus 2B. Again, they're squished right next to each other. There's an invisible times sign, 2 times B, 2 groups of B. So if you want to find the perimeter, you could add, or you could take 2 groups of one side. This is a rectangle, remember, 2 groups of one side, plus 2 groups of the other side. That's the formula for finding the perimeter of a rectangle. All right, so there it is. There's perimeter person. I hope you enjoyed it. Let's go on to area now. My computer's a little slow. There it is, area. So area is a different measurement. Area is the amount of space that's inside the shape. And so let me see if it'll let me do this. Oh, not on present mode. Whoops. Uh-oh. Oh, no. You're getting a preview of, there we go, a preview of Area Alien, which is kind of fun too. But let me show you area here. And there's the shape. And so we're really asking how many tiny little squares of different sizes. It could be a tiny little square, an inch by an inch, could be a centimeter by a centimeter, could be a yard by a yard, or mile by a mile, but how many of those fit inside that shape? So to do that, I want to grab one of these, if it'll let me. Let's see if it's going to let me here. There we go. I want to grab one of those and bring it up over here. Oh, I grabbed the wrong thing. Let's undo that. I'm going to grab one of these little squares and drag it up in there. There's one. So the question is, how many of these will fit? There's 2. This is a little slower than I thought. There's 3, etc. Whoops, that one needs to go down a little bit. This one needs to go up a little bit. So I'm covering the surface. If I completely cover the surface, that is the area. So area is measured in square distance units, like square feet, square inches, square meters, because it's how many little squares would cover that whole surface. Now, to show that squared part, you notice that you put, let's see if I can use my highlighting tool here. Well, there it is. Let's see if this works. There we go. Look at this. Square feet. You put that little tiny 2 right up and above the name of the unit of distance. So square feet, square inches. It's a teeny little 2 and it's up and to the right. Square meters. That's how you show it. Now, you might be wondering, okay, what's the formula for finding the area of a rectangle? It is length times width. And we're also going to talk about length times width. We can call it something else too. Now that we're in 6th grade and on into our schooling, we're going to talk about something that's different than length times width. But let's pause, because sometimes kids have a hard time remembering that area is the surface covered on the inside. And so we have Area Alien to help us remember that. So let's go on to Area Alien, and then we'll be back and talk more about this. Hey everyone, we're here to learn about Area Alien. So shout out to Andrew, who is a 7th grader this year. He coined this phrase, Area Alien. So if you know Andrew in 7th grade, go and tell him that we gave him a shout out on a video. So Area Alien, you might remember perimeter person. There's alliteration. They both start with P sounds. Area Alien, they both start with A sounds. So this should help you remember what area is. So you are also going to be drawing your own Area Alien. Now you need a different sheet of paper or page 2 on your computer. Don't try to squish this in on the perimeter person. I actually had to erase because I'm using whiteboards. You just take another sheet of paper for your Area Alien. Now, here's what you're going to need. You're going to need to draw a shape again. I'm drawing the exact same shape that I used for perimeter person. The reason is because it helps me explain to you the difference, but you can draw a different shape if you decide you want to draw a different shape. But Because it's area and we're learning about rectangles right now, we have not learned how to find the area of triangles or trapezoids or rhombuses, rhombi. But if I was you, I would draw something either that's a rectangle or something that can be turned in, cut into rectangles. So my shape isn't a rectangle, but you'll notice if I just made it straight down and cut it into two parts, I could find the area of those two rectangles inside. So this is an okay shape for me. If you'd like to just start with a regular rectangle, you're welcome to do that. We eventually are going to find areas of lots of complex shapes. So pause the video, draw your shape, and just like I did, mark in the distances on the outside. Now we're going to actually be finding the area on the inside, but sometimes we need the distances on the outside to help us find what's inside. So pause the video, make your shape, and then come on back. All right, you have your shape, and I'm getting started with my area alien. So here is my area alien. He's coming in from outer space. You can draw yours as silly or as just straight up as you think aliens would be. So it doesn't have to look like mine, doesn't have to be flying in a spaceship. But here comes area alien. He's an alien, so he's coming from outer space, and he's coming to land on this shape. Now, the thing about these area aliens is they like to hide. They want to blend in. Nobody wants to be an alien coming to Earth and being found out right away. They want to be incognito. So these aliens have something they can do. As soon as they land on a shape, they can change their body to completely cover that surface. So this is the top of a building, like as in we're looking down on it from above, like a bird. So this is the top of a building. So area alien is going to come and land on the top of this building. But if somebody looked up and saw an alien sitting on top of a building, they'd probably call it in, right? So that's not what he's going to do. As soon as he gets out of the ship, he immediately flattens out into all the space and fills up the whole space. So pause this video, draw your alien coming in from outer space, and then come on back and I'll show you about that filling in part. You just pause and draw this, and then I'll show you the next part. All right, look what he does. He lays down flat and he spreads his body completely out. So he takes over the entire inside surface of that shape. That's area. Area is how much flat surface is inside a shape, whether it's rectangle or triangle or trapezoid, doesn't matter. The area is that space inside. So here's area alien. He's pretty happy because he's incognito. Nobody knows he's here. And he's completely flattened himself out to fill up that whole space. Go ahead and draw your area alien filling up your entire space, and then come on back. All right, we're going to calculate how much space area alien is taking up. How we're going to do that, you might remember the area of a rectangle. To find it, we do length times width equals area. Or when we get into sixth grade, and especially as we keep going higher and higher, we might change those words. We might not use a length and width. We might use base times height. Those both equal area. Remember, what we're actually asking ourselves is, how many little squares would we cover over? Is this area alien covering over? How many squares? Well, this right here tells us this is 10, and let's call this, instead of inches, remember in perimeter person we said inches, let's say this is yards. This is the top of a building. It's pretty big. So this is 10 yards this way. So what that means is there's 10 little yard size squares, and a yard is about, for me, it's about from the tip of my finger to my other shoulder. So it's about this distance. That's a yard. There's 10 of them going this way. So we can actually even draw that in if that helps us understand how much space we're covering. All right. So I knew I was drawing 10 lines going this way, so I need to draw 9 lines because I needed 10 spaces. So there's my 10. So this is 10 parts of blocks going that way. But now in order to make them squares, I need to have them going down. Right here, across here is 9. So I need to divide that into 9. So again, I'm going to take my thing and draw it in, cut it into 9. All right, there I did. Now, they didn't quite turn out exactly even, but we're going to pretend they're all even. So what we really want to know is how many little 1-yard squares Area Alien is covering up. So we could do this. We could count. There's 1. There's 2. There's 3. There's 4. Now, we could do that, but that gets to be a lot of counting. You might remember from other grades that instead of having to count every single one of those little ones, we could know that there's 9 across going this way. There's 10 across going that way. 9 times 10 is 90. So you might know that length times width is the area, and it's not just the area, it's the area of a rectangle. Because other shapes have their own formula. So length times width is the area of a rectangle. Base times height, the same thing. Base just means the part on the bottom, and height going up. But it's still 9 times 10. So in this case, in right here in this part of the building where Area Alien is filled up that part, 9 times 10 is 90. Oops, let me get a different marker here. So there's a 90. That's 90. 90, and we're talking about yards, and we'll talk about that they're little squares. So we're going to call it 90 square yards because it's how many of those little 1 by 1 yard squares are there. But have we found the whole answer? No, because Area Alien is taking up this part too. So we have to do the same thing to the second part. We changed it into 2 rectangles. We got to do the same thing to the second part. So we know that this part from here to here is 12. Right there, we know that's 12. We know this part from here to here is 6. So we're making another rectangle. A rectangle that's 12 by 6. We could say length times width, 12 times 6. We could say base. Remember, the base is down on the bottom, but we also know it's the same distance. Base times height, 12 times 6. 12 times 6 is 72. So I know that that is 72. Am I done finding out how big Area Alien is? I need to put those two together, don't I? I need to put 90 plus 72. So I find out the space of all those all together. So I find out my answer, your answer is going to be different, is 162. Remember, it's how many little tiny squares Area Alien covers over when he or she spreads out. How many of those tiny little squares? How many of these squares? So we have to say the answer in squares. How do we do that? We know it's yards, so we put YD as the abbreviation for yards, and then we put a tiny little 2. It's miniature, and it's up above the right-hand side, so we put it like this. We put it like that, a little square yards. You could also write it like this. 162 SQ is the abbreviation for square. YD, you could also abbreviate it, 162 SQYD, square yards. Now, you're going to calculate how big your Area Alien is when they're spreading out to completely cover over all of the surface. How many squares do they cover up when they spread all out to go incognito? Pause and you figure out your square yardage, or, feet or meters or whatever. All right, now you get to show us your Area Alien. Now, if you did yours like I did on a whiteboard, you're just going to take a picture with your phone like I did. Whoops. All right, it's not working. There we go. You're going to take a picture with your phone, and you're going to, or with your device, actually probably even works better if you just take it right on your Chromebook, grab your Chromebook, take a picture of it, and then you're going to insert it into today's assignment. If you drew it right on the computer, easy. You're just going to attach that to today's assignment. But we do need to see your picture of your area alien. We want to see what they look like when they're coming as aliens. And then we also want to see what they look like when they spread all out and how much space they cover. Good luck. Can't wait to see your pictures. All right, we're back. I hope you enjoyed Area Alien. There's a picture of my area alien. Let's go on to talk about the different ways that we can talk about length times width, because we're going to want to talk about the formula for area as well. But we are, aside from length times width, we're also going to talk about base times height. So the base is another way to talk about the distance, the measurement of one of the sides of a shape. So let me grab my pointer here again. There it is. Take a look at this. The base is the distance along the bottom of a polygon. It's the, think about the, it's the distance from kind of from side to side, and it's the part that the shape sits on. We call it the base. It's not the same kind of base like if you have a secret base, and it's not the kind of base like if you're playing baseball and you have to get to a certain spot. This is the part that something sits on, and that's another meaning of the word base. Now, it is also possible some polygons actually have two different bases. And if you take a look at this trapezoid, you can see we have base 1 that's on the bottom, and they call the one that's up on the top that's still the same, the kind of like parallel there, they call that base 2. So it is possible to have more than one base. We usually think of the base as the bottom sitting on part, but in the case of a shape like this, where there's two different lengths of measures and they're both sort of parallel to each other, we also call that a second base. So we get a base 1 and base 2. Again, confusing and different than baseball, not first base, second base, but rather sort of platforms on the shape. Let me get rid of my highlighted pointer here. And then not only do we need to know about the base of the shape, but we also need to know about the height. The height is how tall it is, how tall something is, the distance from the top to the bottom or the bottom to the top. And it has to go from the very lowest part of the shape to the very tallest part of the shape. So height tells how tall the shape is. And you'll notice that in a rectangle, it's just the side. And in a trapezoid, it's actually not along the slanted part. It's, if you counted straight from the bottom, measured straight up to the top, that's the height. We'll talk more about that when we study trapezoids. Now, one more thing you're going to want to know for today's lesson, formula. This might be the first time you've used this word formula, aside from maybe if you're talking about feeding babies. Something like milk that you feed babies is called formula as well. This is not that. This is math formula. Formulas in math are used to calculate the area and the perimeter of rectangles, and it's brand new in 6th grade. So the formula actually shows in all formulas that you'll learn about all from 6th grade all the way through 12th grade and even into college and into life as an adult, formulas show a mathematical relationship. They use numbers and letters, and they use the letters to represent how to solve that kind of problem, no matter what numbers you put in. So that's kind of cool. These formulas always work no matter what different numbers you put in, including if they're decimals, fractions, negative numbers, they always work. So the formula for the area of a rectangle is base times height. You also probably remember that from lower grades as length times width. The formula for the perimeter of a rectangle is 2 groups of the length plus 2 groups of the width. So the formulas, no matter what numbers you put in, they always help you find the area of a rectangle. They always help you find the perimeter of a rectangle. So let's also talk about finding the area of rectangles. When we're finding the area of rectangles, You often have two numbers, but it's really important to know they might not be the base and the height. If you have the base and the height, you know base times height is the area. Easy. So take a look right here. Let me change into my pointer again. There we go. If you have the base is 7 and the height is 10, 7 times 10 is 70. You've got the area. Base times height will give you the area no matter what the numbers are. But let's take a look here. What if the base is 2 miles? The height is 6 miles. 2 times 6? That's one we're familiar with. We know how to find 2 times 6. 12 miles. Easy. But sometimes we have 2 of the 3 numbers we need, and the missing one isn't the area. Sometimes we know the area, but we don't know one of the sides. So, for instance, if we knew that the base was 7, we don't know how tall it is, but we know the whole space in the middle gives us 28. The base is 7. All of this space is 28. We don't know how high this side is. Uh-oh, my computer's doing something funky here. Hold on. Oh my goodness. Sorry, my computer is interrupting me here. Hold on. All right. What about if we don't know what the base is? It's some distance. We don't know what it is. We know the height is 5 yards. We know inside this covering is 15 yards. How can we figure out what the base is? This is a mystery. Mystery number times 5 gives us 15. Well, we know 3 times 5 gives us 15. So we can figure out missing numbers just because we know that the base times the height always gives us the area of a rectangle. And using that formula, we can figure out the missing numbers. So, good luck. Remember, if you have questions, come and see me in office hours. See you next time.